In the beginning, there was nothing. No earth, no stars, no galaxies, no matter, no energy, and not even space. The Big Bang did not happen in the vacuum of space because space itself did not exist. There was no passage of time because there was no such thing as time. Out of this nothingness came a fireball smaller than an atom, trillions of times hotter than the core of the sun. The universe, our world, plants, animals, and even the water that will form us came out of a point smaller than the nucleus of an atom. Time began. The events that took place after the Big Bang happened in such a short period of time that scientists have invented a new unit of time called Planck time to analyze and make sense of what happened. This unit of time is so small that it is impossible to imagine. 1 Planck time is 10 to the power of minus 43 seconds. Think of the number 1 at the end of 42 zeros in a decimal number system. The future, the code, and the image of the entire universe formed in such a small period of time and determined the next 13.8 billion years. 4 fundamental forces of nature emerged from this fireball in the Big Bang. These were gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. Without these forces, the universe would be a featureless cloud of radiation. These 4 fundamental forces are still at work. Gravity keeps the planets in orbit. Nuclear forces make the stars twinkle, creating the light and electromagnetic radiation that floods our universe. The universe is an elegant collection of over 2 trillion galaxies, each containing 200 billion stars. Earth is the only planet we know of that is currently inhabited by life, but the number of other planets in the universe is unimaginably large. You can tell whether an airplane is getting closer or farther away from you by the wavelength of the sound waves it makes. When scientists first discovered that the universe was expanding, they could tell by looking at the wavelengths of light sent by distant galaxies, just like the sound waves from an airplane. When an object was moving towards us, it shifted blue, and when it was moving away, it shifted red. By observing the degree to which an object was redshifted, astronomers could get a sense of distance. Scientists generally accept the Big Bang theory, which emerged less than 100 years ago. It used to be thought that the universe was infinite and had existed since time immemorial, but today's observations show that all galaxies travel about 1.6 million kilometers per hour. If galaxies are moving away from each other, it means that they used to be all together. The universe is expanding outward from a certain point. This is the first evidence that the universe had a beginning. The second piece of evidence was discovered in the 1960s. Scientists built a giant antenna at Bell Laboratories in New Jersey, USA, to communicate with other satellites. This antenna converted radio waves into light. In 1964, they noticed constant interference while looking at radio waves in the gas clouds in the Milky Way with the Horn Antenna Radio Telescope. And this radiation was coming from all directions. They thought something was wrong with the experiment, but the interference wouldn't stop. They started looking for the source of the radiation, and they realized that it was something that wasn't on Earth, that was actually coming from deep space and from everywhere. It was the echo of the beginning of time. The Big Bang was so powerful and hot that remnants of that heat could still be found. This weak radiation that keeps reaching the Earth is called the cosmic microwave background radiation today. The meaningless blank screen that appears when you flip through the television channels is a kind of remnant of the Big Bang. So, how did the universe transform from pure energy into matter? We know that everything around us is made of matter, and matter is made of atoms. The air we breathe, our houses, our cars, our food. The emergence of matter was a mystery until 1905. Then, Albert Einstein came up with the famous equation, E equals mc squared. Einstein's equation showed us that energy, E, and mass, m, are different forms of the same thing. Mass and energy were interchangeable. Some scientists later used this equation to create the deadliest weapon in history, the atomic bomb. So we have an idea of what happened in the universe's early moments. In an atomic bomb explosion, matter particles are blown apart to create huge amounts of energy. After the Big Bang, the opposite happened. Some of the huge energy was converted into matter. Einstein's equation led us to a conclusion. As the infant universe grew and cooled, the pure energy of the Big Bang disintegrated into the particles of matter that make up us. Everything around us is made of matter created by the energy of the Big Bang. Every molecule, every atom, every quark. After the emergence of matter, over billions of years, vast clouds of gas and dust came together to form galaxies. Galaxies formed star systems, and star systems formed planets. Finally, life appeared on some of these infinitely many planets. We know for certain that it appeared on at least one of them. And today, we, the most advanced species of these organisms, have begun to understand and reveal all the splendor and secrets of the universe. We have begun to uncover the universe's secrets, but we are only at the beginning. After all, we cannot go beyond this three-dimensional world we are in. Who knows what we could discover if we could move to other dimensions? According to string theory, the way to unify all types of particles in the universe is to accept the existence of an 11-dimensional space. In addition to the three-dimensional space and one-dimensional time that we perceive, there are 7 other invisible dimensions. These dimensions curve in on themselves like an ellipse or a bagel, creating a complex space-time structure. At the moment of the Big Bang, the extremely hot universe consisted of a single space dimension. What we call space in the universe was just a line with no width, and two-dimensional Euclidean geometry, that is, flat geometry, was sufficient to define space-time. As the universe cooled, it expanded and unfolded like a leaf in space, forming a two-dimensional plane. Today we can see 4 dimensions in the universe: length, width, height, and time. The other 7 dimensions are hidden. However, new calculations show that as the universe ages, the number of dimensions we can see will increase. The aging universe will unfold like phyllo dough, and first, the 5th dimension will become visible, and then the other hidden dimensions will become visible. So what is this 4th dimension, and what is the 5th dimension? Unfortunately, our brain fails even to imagine it. Leaving the time dimension aside, what can it mean for the 3D world we are in to move to the 4th dimension? An example of one dimension is a line. In this dimension, you can only go forward and backward. An example of 2 dimensions would be a square. In 3 dimensions, depth comes into play, and you can move back and forth, left and right, up and down. We don't know what kind of direction comes into play in the 4th dimension, but this hypercube called a tesseract allows us to imagine the 4th dimension to some extent. But of course, we will never be able to really understand the 4th dimension. Because of our perceptions, our sense organs don't allow it, and the universe we live in is a 3D universe. So, what would happen if we lived in a 2D world? Then we wouldn't even be able to imagine the 3rd dimension. Dr. Quantum explains how this could happen. Here is the 2D world with Dr. Quantum.
Welcome to Flatland. A world of only 2 dimensions. Only forwards and backwards, left and right. In this world, there is no up and no down.
I said to Ray, "Where's Dottie?" He said, "Well, she's out in line."
Where's that from? What the bleep is that thing?
In this world, the 2-dimensional beings that live here have no concept of 3-dimensional objects. These 2-dimensional flatlanders have no understanding of cubes, spheres, tetrahedrons, or yours truly. From their 2D perspective, my 3D finger looks something like this.
What the letter does that?
Hello, little circle. Fear of the unknown. Or should I say, not yet known. It's a puzzle. If we see only what we know, how does anyone ever see anything new? The unknown. How do we ever get out of our box? Hello, little circle. Don't be afraid.
Who said that? Where are you?
This is always the tricky part to explain. I'm in another dimension, another space. I am above you.
No, never use that word.
What word?
The A word.
Above?
It's forbidden.
Well, what do you think it means?
I don't know, and I don't want to know. You can be severely punished if you use that word. Are you a ghost?
I hope not. I just have a different perspective than you do. I can see things in a way you can't yet.
Oh, yeah? Like what?
Well, okay, you have a safe hidden in your pantry. And inside it, you have 12 coins, a will, and a passport.
How did you know that? What are you? Are you a god?
Well, no more than you. You see, since I am above you, in the third dimension, I can see inside things in your world.
Third dimension? You are a crazy ghost. There's only two. Look.
So, if I were to touch the inside of your stomach, how would I do that?
Well, you'd have to cut through my skin. Otherwise, it's impossible. Stop!
Ready for more?
More what?
Dimensions.
Oh.
Directions.
No. Yes, but there aren't any. More? What will happen to me? What will I become?
You'd have to become it to know.